So, calculus can be divided in two parts. Differential calculus, which deals with derivatives, and integral calculus, which of course deals with integral. So we are getting into derivatives today. Yes.
What does that mean? What is derivative?
Funny you should ask.
I'm being so serious on that.
Because a derivative is the slope of the tan line at any point in the domain. Yes.
To be honest, I already knew the shortcut because we got taught it in pre-cal, but I didn't use it.
Thank you, man.
I might have failed the test, but I was honest about that.
What?
I
did grade pre-cal left-hand functions, and they were whole packets. Hey, look, the problems in this book are the same as the problems in the old book. All right. Notation. Let's talk about the notation. There are tons of different ways that we can indicate the derivative of a function. I know. F prime of x tells us that it's the derivative of f at x. We could say, hold on, y prime. Yeah. Yep. dy dx. You will see that a lot. That's if I'm using y equals, I would use dy dx. That's probably the most common notation. Df dx if I defined my function as f equals. Or the d means the derivative of f with respect to x. The f of x is written like, let me erase it. Couple of notes about derivatives. Notes about the first thing, the domain of the derivative is all points in the domain of the function for which, it's a little wordy, I'm sorry. The limit exists. So if the limit does not exist, I am not differentiable at that point. Okay, so my domain both sides, yes. If the limit does not exist, it's not part of the derivative. And we'll talk more about that later.
Okay, what does that mean? Does it mean the point or the whole derivative?
You can be differentiable, is what we say, at a point, but it doesn't apply to the entire function. So I might have something that has just one point where the limit does not exist, but on all the other places, I could take the derivative.
So if the limit does not exist, you're not
Right. But we're right. The point I'm getting at here is that the domain of the domain of the derivative could be smaller than the domain of the function itself, or it might equal the function. It's never going to be more, but it could be smaller than. So there might be some points left out that I can't take the derivative at a certain spot, if that makes sense.
Every time you say derivative,
Yes, that's what it means. So we'll say if f prime of x exists, we say we're only missing one. There's your vocabulary word. If the derivative exists, then we say that the function is differentiable at that point.
wow, that's a big old word.
Differentiable. Say it with me, Van. Differentiable.
I'm gonna go home and tell my mom that's what I was saying.
If a function is differentiable, what does differentiable mean again? You can take the limit exists, I can take the derivative at that point. If a function is differentiable, I'm probably saying it wrong because I'm country. Differentiable. Yeah, it's probably supposed to be differentiable. If a function is differentiable on its whole domain, then we say it's a differentiable function. This is really wordy, but just so that you know, as you see things that pop up, if it says that we have a differentiable function, that means the limit exists everywhere on the entire domain. I can always take the derivative. I know it sounds worse than what it is. I promise. I promise. Do what?
Oh yeah, it wasn't that hard. It wasn't even that bad. You're probably also tired too.
All right. Let me give you an example. Then I'm going to show you an alternate way to find the derivative, and then something else.
Alternate way to find it.
What time do we get done here? 9:55.
Right now.
Find the derivative at a equals 0.
Give me 1 second. Okay. The derivative is.
And I said a equals 0 because that's the way your book gives you, but really it's x equals 0. But find the derivative at x equals 0. You know how to find the derivative. I used a different word there to describe it, but it's what you've already been doing. Yes, you have to use iron. You're exactly right.
I'm not I'm adding stuff on it. Stuff on it. I totally like. But once you get it, oh, it's kind
This one's hard. No, it's not because I'm using 0. Right?
So you got oil. No.
Well, but 0 plus h is just h.
Oh no.
Or I would have
Wait,
had to.
I thought you do x plus h plus x plus h plus l plus x. I'm doing that wrong.
What?
Boil it out.
But because I've got 0 in here, what is 0 plus h? So really that's f of h minus f of 0.
Wait, so let's pretend that x was, let's say that x was 1. What would the inside of the f of x plus h look like after that? Because that's what like. What?
Because to find that it's the limit is h goes to 0, f of x plus h minus f of x over h. Wait, what? Are we confused?
I just
Or
want
am I
to know one
confused?
thing.
Why is there plus 8?
It's x cubed plus x. Yeah, exactly.
So yeah, if you put 0 plus h cubed plus 0 plus h.
So everywhere there's an f of you put. That's just what always.
That's f of 0. F of 0. Right?
Yeah, but you did lose there.
I forgot to plug in.
But don't you have to do the whole function? Like, okay, so what I'm saying is f of x plus h cubed plus x plus h plus x cubed plus. Yeah, h is 0.
Right.
But then you still have another h in there. Can you show me? You make the answer 1. That's what I said. Yeah. Like, pretend x is 1 and show us.
That's a lot more work. Okay, let me do. This one would be 0.
It's just h squared.
Yeah. But when you cancel out the h's, you get a 1. No, you get a 1. It's not just going.
Right. So it's fine. Sorry. Yeah. Y'all are confusing me because I don't even know what y'all are asking right now. Okay, f of x plus h. My x I know is 0, right? Because that's what it told me to start with. So I'm finding f of 0 plus h. We agree with that for this very first one. So what is f of 0 plus h? 0 plus h is, I can simplify that before I even do anything else. So now take this original f of x. So this would be h cubed plus h.
So now let's pretend that instead that x is not a 0.
If that x had been a 1, then it would be 1 plus h. And so it would be 1 plus h to the third plus 1 plus h. Because it's h cubed plus h. But that would be a double FOIL situation. So, right. Right, you FOIL it twice. It'd be double FOIL. All right, so the slope of the tan line. So f prime of 0. All right, so h to the third plus h over h is the same thing as h cubed. 0, plugged in 0. The slope of the tan line at 0 is 1. Does that make sense? Okay.
Can you hold on for a second so I can write on this down? We have a whole week off in
I was gonna say it's still technically summer.
How do you feel about our whole week off?
Going to Disney World.
What is that?
I was gonna,
A shortcut. I'm going to show you an alternate formula. It's a little easier to use than the h approaches 0 formula. I won't go into deriving it because the derivative at a point A, and I am not going to lie, I am not as good with this because this is not something that used to be tested on, this alternate formula. I like the original formula myself, but if you use this, it is justification enough. But the derivative at A could also be described as the limit. That's a value there. As x approaches A of f of x minus f of A over x minus A. I do too. But it's probably because you're so used to it. But just to show you that it works, it's now a standard, so. Let's do one from your homework using this alternate formula. This is number 7. This one's a little different. Instead of taking h and finding where the difference between the 2 points is 0, what I'm essentially doing is it's delta y over delta x. Yeah. We're finding the same thing, just a different way. It's basically a rock, but you're right. The difference is, yeah. I'm doing the limit as I approach A. So, for instance, find the derivative, find f prime of 3. Using the alternate formula here. All right, so look at what we need. We need f of x. Yes. All right, f of x is square root of x plus 1. F of a would be the square root of 3 plus 1, which is 2. Yes. Just 2. Just take the positive. All right, so let's do this. Let's plug in.
Oh, I didn't see that. All right.
Okay. F of x minus f of a over I forgot my limit on the front. It's a square root. So how do we solve it from there? What are we going to do?
Yeah, no, hold on. Give me just a little second to copy it.
Okay, sorry. We're going to have to do a little manipulation.
The two, she got the 2 from the square root.
It's f of x minus, this should have a limit as x approaches. What's a? 3. So it's f of x, it's the limit as x approaches a of f of x minus f of a over x minus a. I'm sorry. Mm-hmm. F of a would be 2. You lost me there for a minute.
So we were down to a equals 3. So we would not be square root x plus 1 minus 2.
F of a is, yeah. It's f of x minus f of a. So you have to plug a into f of x. And a is 3. So the square root of 3 plus 1.
Yeah, f of a is, in the problem it has it written down as f of a. So I see a problem. I can look at that.
Yeah.
Take a look. Oh, okay.
Bless you.
So how do you know that f is?
Because it told me that a was 3. Yes, that's what it told me in the beginning. It says f of x equals square root of x plus 1. A equals 3.
It's just hard for me to know that. Like, if I had another problem like that, I wouldn't know that f of a would be square root of 3.
Well, you're always going back to, this is the original problem.
I wouldn't know that.
Yeah, but if, okay, so even if I had,
One over 2.
f of a, yeah, he said he didn't understand where.
You just substitute. Okay.
Same concept here.
Write that one.
Okay.
Yeah, Alina never got this together, remember? She's been talking like Alright, yeah, so here. Alright, I'm getting it out.
Okay, you're welcome.
We do manipulation.
Yes, we're going to have to do some manipulation here. So the only thing I see I can do, and most of the time when you see a radical, we're going to start multiplying by conjugates. I'm thinking if I multiply the top here by the square root of x plus 1 plus 2.
So it'll cancel.
Right. Right. It should get rid of that square root. My goal is to manipulate this in some way to rewrite it so that something's going to cancel somewhere that is going to allow me to plug in this 3. I'm back to trying to evaluate this limit, but I can't have a 0 in the bottom. It's the exact same thing what they're doing. It's just a new formula is what it is. All right, well, look up to this becomes x plus 1. This and this cancels. Minus 4 over. The conjugates cancel out, that's right. The 2 square roots cancel each other out.
When you multiply something by itself,
Anytime you see a radical and you're adding or subtracting.
Wait, so then you had to FOIL
It is, but remember my goal is that if I plug this in, I'm not going to get a 0 down here. That's okay. A 0 up top is fine, a 0 in the bottom is not fine. No, the top doesn't matter. The bottom would be a vertical aspect.
Just let her finish the poem, everybody. Come on now.
Certainly may use it, but look whenever we get here. If I don't FOIL that out on the bottom, okay? So let's leave that bottom. Don't FOIL it. Look what happens. X minus 3 times the square root of x plus 1 plus 2. Remember, that's what we're looking for all the time, is looking for something to cancel. We're looking to plug the hole. That's right. Now the limit as x approaches 3. It's a 1 on top.
X plus 1
It was in the original.
How'd you get that x minus 3?
All right, go back to the original problem. Remember, it's x minus a. I'm sorry, we'll do one more with the alternate formula if you're an alternate formula fan. Obviously, I'm not. Now you can plug in 3. That's exactly right. One-fourth. You like it? There's one in every bunch. No, I'm just kidding. I bet nobody's ever said that to you before, have they? I'm so smart. Right now?
No, let's keep going.
Okay, when can you drop the one?
What are you going to say?
When you evaluate the limit. All right, let's do one more like this. These are coming from your homework anyway. We're just kind of working through homework together. Yeah. Yes, it works. Okay, so we've got 2 formulas, and I just want to make sure we're clear that we're doing the same thing. The limit is h approaches 0, f of x plus h minus f of x over h, which is the same thing as the limit as x approaches a of f of x minus f of a over x minus a. Okay, same things here. This is the alternate, this is the difference quotient.
So the limit is x approaches a. So what is the difference of How would A be comparable to this other equation?
The value that you're given here at x equals that. Let me show you. And let's do this two different ways and let's see. If you like the difference quotient, use that. If you like the alternate, use that. But we'll work it out both ways. Let's say I told you that f of x was x squared plus 4. And I said find f prime of uno. So find it both ways and let's see which one. So don't look, don't cheat. Remembered what? I never knew what they said right there. I always make up my own words to songs whenever I don't know. Like that song, you know that song? I always thought it was raspberry meringue.
Raspberry beret.
But it's beret. And my whole 38 years I've been singing the song wrong. And my husband said,
Oh wait,
I didn't know, but that's what it sounds like. I have a tendency to do that with songs. Yes, I'm gonna do both of them. Ah,
his boss's name is Mr.
who? Really? Saw that either. That's not nice. Which method? Has anybody done all the methods yet? I got 2 using the difference question.
Wait, that was the difference.
Yeah. Okay, let me do it the other way. You should get the same thing. This time I'm doing the limit as x approaches 1 of f of x minus f of 1 over x minus 1. So I got the limit as x goes to 1 of x squared plus 4 minus f of 1, we already know is going to be 5.
It would be 1 squared plus 4, right? 1 squared.
It'd be x squared minus 1 over x minus 1. I recognize that that's a difference of 2 squares. So I can factor that. Remember, I got to get that whole plug some way. Let me research a little bit and make sure for sure it's not going to show up on your exam. If it does not show up on the exam, you do not have to. But I want to make sure. For some reason, I'm thinking last year they put it on there. No, but they do give me a list of standards that's covered. All right. Oh, really? They don't do that for us.
question, so, period.
All right. I think we're going to stop there. The trick is not going to come until probably Monday.
I like the difference. I like the difference one because I feel like I'm
Tomorrow